So you may or may not already know that any linear equation can be written in the form y is equal to mx plus b, where m is the slope of the line, the same slope that we've been dealing with the last few videos, the rise over run of the line, or the inclination of the line, and b is the y-intercept. Y-intercept. I think it's pretty easy to verify that b is a y-intercept. The way you verify that is you substitute x is equal to 0. If you get x is equal to 0, remember x is equal to 0, that means that's where we're going to intercept the y-axis. If x is equal to 0, this equation becomes y is equal to m times 0 plus b. M times 0 is just going to be 0. I don't care what m is, so then y is going to be equal to b. Y is equal to b. So the point 0, b is going to be on that line. So 0, b. So the line will intercept the y-axis at the point y is equal to b. And we'll see that with actual numbers in the next few videos. And just to verify for you that m is really the slope, let's just try some numbers out. We know when we know the point 0, b is on the line. What happens when x is equal to 1? When x is equal to 1, you get y is equal to m times 1, or it's equal to m plus b. So we also know that the point 1 m plus b is also on the line, right? This is just the y value. So what's the slope between that point and that point? Well, let's take this as the endpoint. So you have m plus b, our change in y, m plus b minus b, over our change in x, over 1 minus 0. Right? This is our change in y over change in x. We're using 2 points. That's our endpoint. That's our starting point. So if you simplify this, b minus b is 0. 1 minus 0 is 1. So you get m over 1, or you get equal to m. So hopefully you're satisfied. And hopefully I didn't confuse you by staying in the abstract with all of these variables here. But this is definitely going to be the slope, and this is definitely going to be the y-intercept. Now, given that, what I want to do in this exercise is look at these graphs and then use the already drawn graphs to figure out the equation. So we're going to look at these, figure out the slopes, figure out the y-intercepts, and then know the equation. So let's do this line A first. Let's do line A right here. So what is A's slope? What is A's slope? So let's start at some arbitrary point. Let's say let's start right over there. And then let us see, and we want to get to even numbers. So let's see, if we run 1, 2, 3. So if our delta x is equal to 3, right? 1, 2, 3. Our delta y, and I'm just doing it because I want to hit an even number here. Our delta y is equal to, we go down by 2. It's equal to negative 2. So for A, change in y for a change in x, when our change in x is 3, our change in y is negative 2. So our slope is negative 2/3. When we go over by 3, we're going to go down by 2. Or if we go over by 1, we're going to go down by 2/3. You can't exactly see it there, but you definitely see it when you go over by 3. So that's our slope. We've essentially done half of that problem. Now we have to figure out the y-intercept. So that right there is our m. Now what is our b, our y-intercept? Well, where does this intersect the y-axis? Well, we already said the slope is 2/3, so this is the point y is equal to 2. When we go over by 1 to the right, we would have gone down by 2/3. So this right here must be the point 1 1/3. Or another way to say it, we could say it's 4/3. That's the point y is equal to 4/3 right there, right? A little bit more than 1, about 1 1/3. So we could say b is equal to 4/3. And so we'll know that the equation is y is equal to m, negative 2/3, x plus b, plus 4/3. That's equation A. Let's do equation B. Hopefully we won't have to deal with as many fractions here. Equation B, let's figure out its slope first. Let's start at some reasonable point. Let's see. We could start at that point. And then if we, let me do it right here. B, equation B. When our delta x is equal to, let me write it this way, delta x. So our delta x could be 1. When we move over 1 to the right, what happens to our delta y? We go up by 3. Delta x, delta y. Our change in y is 3. So delta y over delta x. When we go to the right, our change in x is 1. Our change in x is 1. Our change in y is positive 3. So our slope is equal to 3. What is our y-intercept? Well, when x is equal to 0, y is equal to 1. So b is equal to 1. So this was a lot easier. Here the equation is y is equal to 3x plus 1. Let's do that last line there. Line C. Line C. All right. So let's do the y-intercept first. You see immediately the y-intercept, when x is equal to 0, y is negative 2. So b is equal to negative 2. And then what is the slope? M is equal to change in y over change in x. So let's see. Let's start at that y-intercept. And if we go over to the right by 1, 2, 3, 4, so our change in x is equal to 4. What is our change in y? Our change in y is positive 2. Change in y is equal to 2. So change in y is 2 when change in x is 4, or the slope is equal to 1/2, 2 over 4. So the equation here is y is equal to 1/2 x, that's our slope, minus 2. And we're done. Now let's go the other way. Let's look at some equations of lines, knowing that this is the slope and this is the y-intercept. That's the m, that's the b, and actually graph them. So let's do this first line. I already started circling it in orange. The y-intercept is 5. When x is equal to 0, y is equal to 5. You can verify that on the equation. So when x is equal to 0, y is equal to 1, 2, 3, 4, 5. That's the y-intercept. And then the slope is 2. That means when I move 1 in the x direction, I move up 2 in the y direction. So if I move 1 in the x direction, I move up 2 in the y direction. If I move 1 in the x direction, I move up 2 in the y direction. If I move back 1 in the x direction, I move down 2 in the y direction. If I move back 1 in the x direction, I move down 2 in the y direction. I keep doing that. So this line is going to look, I can't draw lines too neatly, but this is going to be my best shot. It's going to look something like that. And it'll just keep going on and on and on. So that's our first line. And I could just keep going down like that. Now let's do this second line. Y is equal to negative 0.2x plus 7. So let me write that. Y is equal to negative 0.2x plus 7. So it's always easier to think in fractions. So 0.2 is the same thing as 1/5. So we could write y is equal to negative 1/5 x plus 7. So we know its y-intercept, it's 7. So this is 1, 2, 3, 4, 5, 6. That's our y-intercept when x is equal to 0. And this tells us that for every 5 we move to the right, we move down 1. So we could view this as negative 1 over 5. That delta y over delta x is equal to negative 1 over 5. For every 5 we move to the right, we move down 1. So every 5, 1, 2, 3, 4, 5. We moved 5 to the right. That means we must move down 1. We move 5 to the right. 1, 2, 3, 4, 5. We must move down 1. If we go backwards, if you move 5 backwards, so if you view, instead of this, you view this as 1 over negative 5. These are obviously equivalent numbers. So if you go back 5, that's negative 5. 1, 2, 3, 4, 5. Then you move up 1. You move up 1. You go back 5. 1, 2, 3, 4, 5. You move up 1. So the line is going to look like this. I have to just connect the dots. I think you get the idea. I just have to connect those dots. I could have drawn it a little bit straighter. Now let's do this one. Y is equal to negative x. Y is equal to negative x. Where's the b term? I don't see any b term. You remember we're saying y is equal to mx plus b. Where's the b? Well, the b is 0. You could view this as plus 0. So here is b is 0. When x is 0, y is 0. So that's our y-intercept right there at the origin. And then the slope, once again, you just see a negative sign. That you could view that as negative 1x plus 0. So the slope is negative 1. When you move to the right by 1, when change in x is 1, change in y is negative 1. When you move up by 1 in x, you go down by 1 in y. Or if you go down by 1 in x, you're going to go up by 1 in y. X and y are going to have opposite signs. They go in opposite directions. So the line is going to look like that. It's going to look like that. You can almost imagine it splitting the second and fourth quadrants. Now I'll do one more. Let's do this last one right here. Y is equal to 3.75. So now you're saying, gee, we're looking for y is equal to mx plus b. Where is this x term? It's completely gone. Well, the reality here is this could be rewritten as y is equal to 0x plus 3.75. Now it makes sense. The slope is 0. No matter how much we change our x, y does not change. Delta y over delta x is equal to 0. I don't care how much you change your x. So our y-intercept is 3.75. So 1, 2, 3.75 is right around there. Just want to get close. 3 3/4. And then as I change x, y will not change. Y is always going to be 3.75. So it's just going to be a horizontal line at y is equal to 3.75. Anyway, hopefully you found this useful.